Hi, I'm Abigail Skalla, a graduate student at Morningside College and a fifth grade teacher in Spencer, Iowa for the Spencer Community School District. This presentation is on the effects of mathematical discourse on student achievement for fifth grade students. The problem is that students are performing low in comparison to other countries and comparison to the past in the area of mathematics. So as you can see nationally, that 40% of grade 4 students scored at or above the proficient level in 2015's NAEP. Then in 2013, 45% of grade 4 students scored at or above the proficient level on the NAEP. So we have gone down from 2013 to 2015. The US was ranked 13th out of 36 nations on the 2007 TIMSS. The nations that were outperforming the United States on that assessment were Singapore, Taiwan, Hong Kong, Korea, and Japan. Those nations were also outperforming the United States by large amounts. Locally, a decline in mathematics achievement is also occurring. In the 2015-2016 school year in Spencer, 44% of grade 5 students scored at or above proficient on the BVSD. The BVSD is the Boulder Valley School District Universal Math Screener. And last year in the 2016-2017 school year, 39% of grade 5 students scored at or above the proficient level. So I asked, why do I need to do this study? Well, this is because our district has had many conversations about moving away from timed math tests because fact fluency is a large problem in our district. And so what we were doing, which was the math time tests, were not working. So we needed a better solution. So past interventions can show us that students are discouraged with their facts and achieving low on math scores by Joel Bowler. And one of the past interventions was time tests. And with time tests, students are having lower scores when they are given a time test. And they also show higher math anxiety when time tests are given. Another past intervention is using flashcards, and low achievement of multiplication facts occurs when students use flashcards. An average of 46 out of 100 facts correct was occurring when learning through multiplication through flashcards. So a little bit closer look into fact fluency and number sense. So when students are fluent and understand their facts, they have number sense. And number sense is that flexible thinking about numbers and understanding the meaning of numbers and understanding the relationship among numbers. Brodeur has 3 phases that students go through when it comes to mastering basic number facts. And those phases include the counting strategies in phase 1, phase 2, the reasoning strategies, and phase 3, mastery. Then Kling and Bay-Williams have strategies within those phases to help students flow through the stages rather than go from counting right to mastery. So an example of the counting stages would be skip counting by your 2s, your 5s, and 10s that students can get right away. Then the phase 2 is using what they know from the phase 1 and reason for the next number. So example would be, I know my 5s, I have that understanding from phase 1, I can use that to reason and understand the answer to my times 6s. And then for mastery, students need frequent opportunities to engage and explore their facts before they can have fact mastery. Another component of this study is mathematical discourse. And mathematical discourse is the discussion students and teachers have about mathematics to demonstrate their understanding. Mathematical discourse also promotes student engagement, and mathematical discourse aligns with the Common Core State Standards math practices, specifically math practice number 3, which states that students construct viable arguments and critique the reasoning of others. For the gap in the research, it was lacking for 5th grade. Also, there is lacking statistical evidence about meaningful math conversations. My research question then was, will mathematical discourse affect students' multiplication and division fact understanding? And the purpose of this study was to increase student achievement in basic computation skills through the use of mathematical discourse with 5th grade students. My hypothesis was that the experimental group would outperform the control group on development of flexibility with learning multiplication and division facts through participating in mathematical discourse and have higher mathematics achievement. The variables for my study were the games were the independent variable, and the dependent variable was mathematical discourse. The participants of my study were 5th grade students from 3 different classrooms, with a total of 75 participants. The participants varied in socioeconomic status and racial background. 30% of the students received free and reduced lunch, 94% were white Caucasian, and 6% were Mexican American. Students were randomly selected with no incentive for this study. Here is some examples of the materials used for this intervention. There were 2 games, the Knock It Off and Division and Multiplication Squares. So Knock It Off and Division were both available in multiplication and division. These games were chosen because they can both encourage discussion and they can focus on one set number type at a time, so they aren't as overwhelming for students. Curriculums used throughout the study were the cognitively guided instruction philosophy and the investigations in number, data, and space for Common Core by Pearson. Both of these resources were required by the district. The assessment, the pre and post assessment then for this study was the cognitive-based assessment. And this assessment was adapted from the multiplication and division cognitive-based assessments written by Michael Batista. These assessments were created to monitor, understand, and guide students' development in mathematical thinking. These assessments also align with the CGI philosophy, which was stated previously in the curriculum. The procedure of this study, it was a 12-week study, and students participated in the games intervention 3 times a week for 10 minutes. The first 4 weeks were focused on multiplication, the next 4 were focused on division, and the last 4 were focused on both multiplication and division combined. The study started with a pre-assessment and ended with a post-assessment. The first 2 days of each of the 4 weeks was devoted to modeling how to play the game. In the experimental group, students were taught and modeled how to have mathematical discourse, where the control group was just taught the games and was not modeled how to have the mathematical discourse. Throughout the weeks, teachers of the experimental group prompted and reminded students to participate in math discourse while playing the games. An independent samples t-test was conducted to examine the research question, does mathematical discourse affect student achievement on basic math facts? An independent sample t-test was the appropriate statistical test when the purpose of the research was to compare the 2 different groups, control group and experimental group. Data on the CBA pre-assessment was compared to the data on the CBA post-assessment. The results showed that there was an increase in math achievement scores as a result of the mathematical discourse while playing the intervention games multiplication and division facts. The hypothesis was confirmed, and the mathematical discourse improved flexibility with multiplication and division facts and improved mathematics achievement. Here we have Table 1, which shows us statistics and p-value for pre and post test. Prior to the intervention, the control groups did not show a difference in math fact understanding on the CBA of multiplication and division pre-test. The experimental group was slightly above the control group on the pre-test. There was a significant difference in the scores for mathematical discourse from pre-test to post-test. These results suggest that mathematical discourse does influence the understanding of math facts. Here is Table 2, and it shows us the means and standard deviations for experimental and control group, the experimental and the control group. The experimental group's mean score on the pre-test, as you can see here, was 53 and 20/100ths, with a standard deviation of 19 and 77/100ths, which was only 5% above the control group's mean score on the pretest. Here in Figure 1, you can see that the results did show a significant change for the experimental group with respect to pre and post-intervention measurements, with the higher post-intervention scores than the pre-intervention scores. Findings indicate that the mathematical discourse during the intervention improved multiplication and division fact number sense for the experimental group. Interpretations of the study and results show that there was a lack of basic computation skills shown to influence fluency with whole numbers and automaticity with basic facts, which contributes to low achievement. The experimental group did increase the gap between the control group and itself. The findings of this study are supported with the results from research around number sense, where students are successful with thinking flexibly about numbers, understanding the meaning of numbers, and understanding relationships among numbers in achievement for mathematics. This study aligned with metacognition learning theory. This learning theory states that students have awareness of their own learning while they are learning. The participants of the experimental group were able to understand how they were learning and then make adjustments of that learning as new facts arose. There are a few limitations from this study. The first is the accountability of all participants. I was uncertain if all participants were sharing accurate and efficient strategies, as well as if they were in the experimental group sharing any thinking at the time. Another limitation was the checking system for the assessment. A question I had while ending this research was, when is having mastery okay and not needing to share understanding on the assessment needed? Because students in the experimental group were starting to have that understanding. They were in that phase 3 of mastery, and I wondered, did they need to provide an explanation on the assessment? So that's where I had that question with that. And then our main goal was to master the facts and have that understanding. So then I kind of wondered, when did explanation need to be needed or not? I also wondered what were long-term effects of basic math fact understanding. So we want retention of mathematical facts. It's essential to our mathematics achievement. So with that being said, I have a few recommendations for future research. So that would be to keep all participants accountable. We could facilitate these games in math centers or rotations, smaller groups working on the games with one adult. Then we could use the assessment as a progression of student thinking and understanding, rather a yes or no right answer. And also with the retention of math facts, it'd be interesting to assess the students again after a time span where they were not actively participating in math discourse around the math facts. Then implications of this study was the use of mathematical discourse in math learning at all times, because it does promote student engagement. Webb et al. Suggests that it is important to have productive math conversations for students, and students can share their own learning as well as participate with the ideas of others. The study also aligns with CGI and the Common Core State standards. And so with CGI, it focuses on student thinking and the process of the students thinking while they're working on mathematics. And as stated before, how this aligns with the Common Core State standards, math practice number 3. Also, a possible impact is that this can help districts decide how they would like to go about when they think about having new instruction for math facts. And so the future instruction of basic math facts will be impacted by whether I decide to select this intervention in the future, or on how I do decide future interventions for math facts in the future. And here are my references for the presentation. Thank you.